Okay, this is section 4.5, applications from business, finance, science, all about kind of logarithms and exponentials, kind of the basic stuff we've been doing in chapter 4, right? So, first, we will start off talking about interest formulas, okay? So the first one, if we have principal P deposited or borrowed at an interest rate R for a period of T years, this is called simple interest, okay? If we have the equation I equals PRT, all right? So the interest is the I, principal's the P, R is the interest rate, and T is the time. Now, interest rate, R is not 3%. R would be equal to 0.03, okay? So make sure to convert it back into a decimal. Okay, next one. The total amount A accumulated or due after the period. So that means kind of, if we're talking about simple interest, that just gives you the interest amount, okay? On top of the amount of principal that you borrowed, okay? And it would maybe have to then pay back. Or if it's principal that you deposited in an account, you just want to know how much growth there was if you do simple interest. However, if you do total amount, that means you're either calculating how much you put into account and then interest added onto it, how much you completely totally have in that account now after so much time. Or that would be, okay, if I have a loan for this long, I borrowed this much at this interest rate, how much would I completely be paying to the bank? Okay, so this is just interest. It would help if I could spell. And this is total amount. Okay, after T time. All right, so these are just the same thing, right? We just multiplied the P through. P times 1 is P, P times RT is PRT, okay? So same thing. And if you notice, this part right here is I. So amount is also just equal to the principal plus the simple interest, right? That completely makes sense because you're saying, okay, I have the principal that I put in or that I borrowed, and then I add on the simple interest to it, okay? So again, this is just simple interest. They must say simple interest to use that problem or that equation, right? Because we have these others, if interest, right, is found by compounding different amounts of times, okay? So this equation is if the interest or amount is compounded in times per year, okay? So that's when this n and this n are the amount of times per year. So if it's annually, well, n is once. If it's quarterly, n is 4, right? Or biannually, then n is 2. Monthly, n is 12, right? There's lots of different ways that we could do it, okay? So that's how we would set up those equations. The next one is, so sorry about that, it's being slightly odd and not showing up. There we go. So if the next one is compounded continuously, okay? So that setup is if we're using the exponential format, that's the A equals PE to the RT. This is very, very similar, if you notice, to the simple interest, right? You have PRT, you just have that exponential thrown in the middle, okay? We've seen this one before. I talked about it just a little bit, just mentioned it more so in the section just on basic exponential functions, right? So, but notice these two are vastly different, but they are almost the same words, right? Compounded in times versus compounded continuously. So if it's a specific amount of times, right, you must use this equation. If it's continuously, then you must use this equation, all right? Only if they talk about simple interest will you use this first one and the second one, okay? So now let's do an example. So first one here is Deborah needs $4,500 for a future project. Okay, so that means she needs a total amount of $4,500, right? So that means probably that A is going to be $4,500. Then she can invest $3,000 now. That's the principal. Anything that you do now or current amounts, right, are principal. So P is equal to 3,000. Then an annual rate of 8.5%. So that's our R. Remember to convert it to a decimal. So 0.085. And it's compounded quarterly. Oh, compounded quarterly, that's this equation. The A equals P times 1 plus R over N to the NT. Okay? So that means we need to know in quarterly. Well, quarterly is 4 times a year, and assuming no withdrawals are made, how long will it take her to have enough money for her project? So how long? That means T is the question, right? So let's plug in everything we know. 4,500 for A is equal to 3,000 for P. 1 plus 0.085 over 4 to the 4t. Okay, we want to solve for t. So that means we should get the t on its own first. Well, it's in an exponential, so that means we should maybe take this 3,000 over first. So 4,500 divided by 3,000 is what? The zeros cancel, and then there's a 5 in both. There's a 15 in both, actually. So that's 3 over 2 is equal to 1 plus 0.085 over 4 to the 4t. Notice they say do not round any intermediate computations. So that's why I'm not doing this division here. Okay, I'm leaving it as it is because it might not divide out. It might, and that's fine. Then you can just add it, right? But it might not. So let's just pretend it didn't for those cases where it doesn't, because it will happen. So then what we have is we have our t in the exponent. Well, what do we do here? We have all of our exponent and log rules, right? So we have that log rule where we can multiply exponents down. So let's use that one. It does not matter what we use, right? So you could use natural log, you could use log base 10. It doesn't matter. It will give you the same amount, which is pretty cool. So let's use log base 10. Just cause. So that means we have log of 3 over 2 is equal to, we want to multiply that down. So we have 4t times log of 1 plus 0.085 over 4. Then just divide. So then t is equal to log of 3 over 2 divided by 4 times log of 1 plus 0.085 over 4. So this is approximately equal to 4.82 because we want to round to the nearest hundredth. Okay, so that's how we deal with that setup. So let's do another example then. The next example is if we have $3,200 borrowed for 6 years at an interest rate of 9.5% per year, compounded continuously. Compounded continuously is the A equals PE to the RT. So that means we need to know A is equal to what? Find the amount owed. Oh, that's what we want to know. P is equal to 3,200 because that's the amount borrowed. E is E. R is 9.5%, so 0.095. Then T is equal to 6 years. So that means we have A equals 3,200 e to the 0.095 times 6. So I would say that the Alex calculator can do all of this at once. Okay, just be careful that the 0.95 and the 6 are both in the exponent, and then you won't have any rounding errors. Okay, so that means A is approximately equal to, we want the nearest cent, so 2 places, 58.45 in dollars. Okay, so it makes sense because there's a positive interest rate, right? And we borrowed 3,200, so that means after 6 years we owe this much. Makes sense that it went up, right? Always think about those kind of things. So next example. So Mr. and Mrs. Hayes hope to send their daughter to college in 11 years. Oh, we already know T is 11 years. Now, how much money should they invest now? Oh, investing now, that's the principal. How much? That's what we want to know. Interest rate of 9% per year, so R is equal to 0.09. Compounded continuously, so that means we have the A pert again. And then in order to be able to contribute $9,500 to her education. So that means we want to be able to get out a future amount of $9,500. So plug in 9,500 is equal to P, because we don't know that, e to the 0.09 times 11. Now notice, we want to solve for P. So just divide by the e to the exponent. So then P is equal to 9,500 over e to the 0.09 times 11. And that's it. Just put that in the calculator and we will get P is approximately equal to, again, nearest cent, so 2 places, 35.29.98 cents. So, well, it makes sense again that it's less because we're talking about how much we should put in now to gain 9% per year to get up to 9,500. So we have 11 years, so it should take a little while, meaning we could start off with a lower amount, right? A much lower amount. Okay, next example, we have the mass of a radioactive substance follows a continuous exponential decay model. Oh, well, we didn't really talk about them with signs added in. It is the same exact equation though, okay? So it's still A equals P e to the RT. However, the book and many different places will make R a different letter, right? We talked about this back with the basic exponential function section. That they write this as A equals P e to the KT, or sometimes altogether different as P of T equals P0 e to the KT, okay? I don't care which one you use. If you just want to remember the A equals PE to the RT, I'm fine with that. It's the same exact equation. And if you know the equation, you can do any continuous thing, right? So this is a decay model. So that means we should expect K or R or whatever to be a negative number, okay? So that's from decay, all right? If it was growth, then we should expect K to be positive, right? All right, so a sample of this radioactive substance has an initial mass of 379. Initial mass, that's P, that's the principal, that's the starting point, right? Or P0 if we use this formula set up, right? So that's 379. Then it decreases continuously at a relative rate of 4% per day. All right, well that's R or K, and it's decreasing, so that means it's negative 0.04. Find the mass of the sample after 3 days. So they gave us t. That's 3 days. So that means we want to know a, or p of t, depending on which model we use, right? Let's use the a pert. So we have a is equal to principal of 379 e to the negative 0.04 times 3. Just plug it in and get a is approximately equal to 427.3. Okay. That doesn't make any sense. So that is actually not the right answer because look at that. We just said this was an exponential decay model. And we just found that 379 went up to 427.3, right, in 3 days. That can't happen. So that means this is actually the wrong answer, okay? That's maybe good to see because now we know what to expect to not get, right? So if it's a decay, we should not have it go up. All right, so that just means we have 0.04 times 3, and that's a negative in the exponent, and we raise it to the e, right, or e to that, times 379, and we should actually get 3336 point nearest tenth. So 0.1. That is our actual answer because 379 goes down to 336.1. Okay, so that's why that one makes sense now. Okay, next is we have the number of bacteria in a certain sample increasing according to the following function, where y0 is the initial number present. This is just exactly the same setup, but with y and y0 instead of p and p0 or a and p. Really, it's just using different variables, okay? It's the same equation though, and the same thought process. So if you even want to rewrite these as a perts, right? That just means this is equal to a equals p e to the 0.0789 t. It does not matter. It's the same thing, right? Okay, so then what do they want to know? How many hours does it take for the size of the sample to double? Okay, so that means we don't know P, we don't know A. We just know from one to the other it doubles. So if we say that P is 1 and A is 2, well then we can calculate this, right? So that means we have 2 equals 1 e to the 0.0789 t. Okay, well the 1, it doesn't really do anything, right? We want to cancel out the e though. We don't want the e there, right? So take the natural log of both sides. Cancels the e, so the natural log of 2 is equal to 0.0789 t. Just divide, so t is equal to natural log of 2 over 0.0789, which then is approximately 8 point, well, it says nearest tenth, right? Okay, so that means we get 8.8. Okay, so that is if it talked about doubling. What if it talked about it's half the size, or it has a half-life? Okay, half-life would just mean that if you start with one thing, then you end up with half of it, right? Or what about if it tripled? Well, that means you start with 1 and you end up with 3. Or it quadrupled. Start with 1 and it ends up with 4, right? So just use the words, start with 1 always, and then whatever it said, that's what A is. okay? It doesn't actually matter what P is though. Only if you actually knew the p-value. Okay, so in this one, we're told that we have an initial mass of 37.4, and the substance follows a continuous exponential decay model. So that's for them, y equals y0 e to the kt, and it has a half-life. That's what we just talked about, right? So let's set that up. For A, we would have y0 would be 1, and then y, it's half-life, so that means it's 1/2. E to the, we don't know k, but we know t is 11 because that's how long it takes to have a half-life. So solve for k. Take the natural log of both sides, cancels, so the natural log of 1/2 is equal to k times 11, divide by 11, so k is equal to the natural log of 1/2 divided by 11. Now notice, it says do not use approximations, use exact expressions. So that means this is equal to 37.4, that's the initial amount, e raised to the natural log of 1/2 over 11 t, okay? That's the equation. Now, how much will be present in 15 hours? That just means take this equation, plug in 15, right? So we have 37.4 e to the natural log of 1/2 over 11 times 15. Plug that in. It is approximately equal to 14.5 milligrams. That's what we would just put in there for our B answer. Okay? So that is the end of 4.5 and the end of chapter 4.